For today's video, we are going to discuss another way to determine whether a series is convergent or divergent, and it is by using a direct comparison test and limit comparison test. So comparison test, suppose that we have two series AN and BN with sequences A and Bn greater than 0, greater than or equal to 0 for all n, and that the sequence An is less than or equal to the sequence Bn for all n. Then, if the series Bn is convergent, then so is the series An. If the series An is divergent, then so is the series Bn. Okay, before I'm going to give you an example on how to use the comparison test, let us have this transformation of graph. Now, this is the graph for the function y is equal to x squared. So, as you can see, yung behavior ng graph natin, when x is less than 0, okay, ibig sabihin, these are negative x values, but as the values of x approaches to 0 from negative, okay, from the negative direction, but as x approaches from the negative direction towards 0, towards the value of 0, ang graph natin is decreasing. Okay, it is decreasing. And then after that, when x is already greater than 0, meaning towards going to the direction of positive values already, our graph is increasing. Okay, so ganun yung behavior ng graph natin for this particular function. Now, let us have another function, y is equals to x squared plus 2. So, if we're going to see the graph, so this is the graph. So, tingnan ninyo, as x, no, from the negative side, as x approaches to 0, the graph is decreasing, nagdi-decrease. But, when x is already more greater than 0, meaning papunta na siya sa positive side, so nag-i-increase na yung x value natin, okay, starting from right after 0, the value of x right after 0, nag-i-increase na ngayon ang ating graph. So what have we observed? We have observed that the two graphs, ang behavior ng two graphs natin ay pareho. They are similar. Pareho yung kanilang behavior. That from the negative side towards, if the value of x is from the negative side towards going to 0, ang graph natin ay nagdi-decrease, but when x is already greater than 0, then our graph is increasing. But take note that we have two different functions. Then the other one is, oh, by the way, so as you can see here, this is our vertex, okay? And then, when we added plus 2 in x squared, pareho naman silang may x squared, but in here, when we added 2, so yung graph natin is nag-move upward by 2 units. Okay, nag-move siya upward by 2 units. Andito na sa 2 ang vertex. And then, in this case, in this example, x squared, y is equals to x squared minus 2, tignan nyo ang graph. Pareho pa rin yung behavior ng graph natin. Nagdi-decrease, tapos nag-i-increase as x approach from negative side approaching to 0, nagdi-decrease ang graph. And then when x is when the x value is greater than 0, approaching to positive side, nag-i-increase na ngayon ang graph natin. So, pareho yung behavior nilang tatlo. However, yung dito, the graph, from the original graph, nag-move upward by 2 units. But in here, since the function is y is equals to x squared minus 2, so the graph moved downward by 2 units. Okay? But take note that their behavior, whether we added plus 2 or minus 2, pareho pa rin yung behavior ng graph natin. Now, let us have this example. Determine if the series 1 over 5 plus 2 raised to n is convergent or divergent. So, we will focus on the given sequence, this one, okay? And then, let us look at another sequence that has a similar behavior in terms of their graph. Katulad ng binanggit ko kanina, di ba, we have the x squared and x squared minus 2, x squared plus 2. Both of the, all the three graphs have the same behavior in terms of their graph. So, ganun din ang gagawin natin. Maghanap tayo ng sequence kung saan pareho yung behavior ng kanilang graph. Because, and then i-compare natin yung dalawang sequence. Because, if we are able to find out that the other sequence is convergent or divergent, most likely itong given series na ito is also convergent or divergent. Okay, so in this case, the other sequence is 1 over 2 raised to n. 1 over 2 raised to n. So again, we will just look at the previous example, yung kanina. So y is equals to x squared. Diba? When we added 2 or when we subtracted 2, still pareho pa rin yung behavior nila. Okay? In this case, pareho din. Okay? Ang nagiging, kumbaga, yung 5 dito is nagiging insignificant siya. Okay? Ito yung nagiging result ng transformation, whether the series will go upward, will go downward, will go sideward, to the left or to the right. Okay? So, itong 5. Ito yung responsible kung saan magta-transform or saan magmo-move yung graph. That is why we can just simply remove it so that we can have the other sequence. So, the other sequence will be 1 over 2 raised to n. Now, let us determine if totoo nga that this one is less than 1 over 2 raised to n. Let's see. Now, we know that if the denominator is greater than to the other denominator of the other fraction, then most definitely, itong fraction na ito is less than to this one. Just like, for example, this one. 1 over, for example, we have 4 plus 5. And then the other one is 1 over 5. Okay, 1 over 5. So again, we have the same number of 5 here, but in here we added 4. Okay? So, this will be equal to 1 over 9, and this one is still 1 over 5. Remember, diba, in fraction, if they have the same numerator, but of different denominator, then this fraction has a greater denominator as compared to this one, then therefore, this fraction is less than to this one. And totoo naman talaga, because 1 over 9 is less than 1 over 5. So, ganito rin, itong concept na ito, i-apply din natin dito. So, we have the same 2n, but we added 5 here. So most definitely, itong fraction na ito is less than or equal to 1 over 2n. Actually, it is really less than 1 over 2n, but we are just simply, well, pwede rin naman less than lang ang gagamitin natin, but I just used less than or equal to because of the sa condition sa comparison test. But again, you can use this one or this one. Okay, now let me again reiterate that ang behavior ng graph nilang dalawa, ang behavior ng graph ng dalawang sequence na ito ay pareho. Okay, pareho. Now, since this sequence is less than to this sequence, that is the same as with the series. So this series is less than to this series. Okay. Now this one, do not be confused. They are equivalent. Okay. We just simply rewrite it. Pero equivalent pa rin sila. Pareho lang yan sila. Ang 1 over 2 raised to n at saka ang 1/2 raised to n. Okay, now, given these two series, if you are going to observe, it's much easier to determine this, whether this series is convergent or divergent kasi mas simplified siya as compared to this one. Diba? Kasi nga may additional 5 tayo. So, we will determine itong series na ito if it's convergent or divergent. Now, based from the previous videos, we have determined that this is a geometric series. This is a geometric series in which the r is 1/2. Okay, and then there is a theorem that if r is less than 1, then the geometric series is convergent. Okay, convergent. Therefore, this series is convergent. Okay. So, this series is convergent. Okay, so again, we were able to find out that this series is convergent and based kanina sa condition under sa comparison test that Bn is greater than or equal to An. Okay, there was a condition like this. And so, since ito naman is greater than to this, therefore, ito ang Bn natin at ito naman ang ating An. And with that, following the condition that if the series Bn is convergent, then the series An is also convergent. Since na-prove natin that this one, which is Bn, is convergent, therefore we can say that, given also this condition, we can say that the series 1 over 5 plus 2 raised to n, which is series An, is convergent. Here is another example. So determine if the series n plus 5 over n squared is convergent or divergent. So let us focus on this given sequence. Okay, so again, following the concept yung sa transformation graph. Okay, so in here we can say that plus 5 here, the 5 here is insignificant. So we will remove that and we will compare the entire sequence to this sequence. Again, kinuha natin yung concept dito, yung sa transformation graph, yung y is equals to x squared, then x squared minus 2 and x squared plus 2. Okay? Kinuha natin yung concept na ito doon. So, with that, we can say that the graph of these two sequences are similar. Okay, similar yung behavior ng graph nilang dalawa. That is why, if we find out that the graph of this one, or the series, this series is convergent, then ito convergent din. Pero kung divergent ito, then divergent din ito. Or the other way around. If this is divergent, then most definitely this is also divergent. Kung convergent ito, then ito convergent din. Okay? Kasi similar nga yung behavior nila. Behavior ng graph nila. Okay. Now, let us try to see if this is correct. Okay, so let's have, for example, n, then n squared, then yung isa n plus 5, n squared. Again, okay, let us have, so we have n over n squared plus 5, then yung isa is n over n squared. So let's say we have n as 1, so we have 1 plus 5, and then 1 squared, then yung isa naman is 1 over 1 squared. So this is 6 over 1, then yung isa naman is 1 over 1, so that is 6 and 1. So 6 is greater than 1. So ibig sabihin, this one is greater than to this one. So this is correct. This is correct. And that is true for all n. Kahit anong n ang isa-substitute natin dito, still, this sequence will be greater than to this one. Okay? Kasi nga, di ba we have this concept that, okay, ito pareho kasi sila, pareho n over n squared, but since we added another 5 value here, so therefore, mas lumaki yung denominator nito kesa dito. And alam natin kapag mas malaki yung denominator, okay, in a fraction na, sa concept ng fraction, kapag malaki ang denominator, let's say we have 5 over 3 as compared to 2 over 3. So, pareho yung denominator, pero magkaiba yung numerator, and then mas malaki yung numerator nito kesa dito, then we can say that 5/3 is greater than 2/3. Okay. So therefore, for all n, this is true. Okay, so that is also true for series. Okay, for the series. Now again, this one is pareho lang yan sila. It's just that we already simplified it. Okay, simplify na natin. Okay. Then let us identify which one is AN, which one is BN. Okay, so ang AN natin, okay, so this is our AN, and this is our BN. Kasi nga, di ba, according, okay, dito pa lang i-identify na natin that this is BN and this is AN. That is part of the condition under sa comparison test that BN is greater than or equal to AN. And then, after that, tingnan niyo, given these two series, mas easy kung kukunin natin yung, o i-identify natin itong series na to, kung convergent ba or divergent, kasi mas easy. Okay, mas easy ito. And so, based from the previous videos natin, we have identified that the series 1 over n is a divergent series. Okay, we have proven it based sa, we have proven it and we have shown it sa ibang videos natin. Okay, that the series 1 over n is divergent. Now, since, okay, ang series 1 over n is ito, an. And then, let us look back sa comparison test. Sinabi doon sa comparison test that if the series an is divergent, then the series Bn is also divergent. Therefore, we can say that the series n plus 5 over n squared is divergent. Here is another way to determine if the series is divergent or convergent. using limit comparison test. Suppose that we have two series. We have the series AN and the series BN, with AN greater than or equal to 0 and BN greater than 0 for all n. Now, AN can be equal to 0 because AN is in numerator. Okay, so we are it's allowed to have a 0 value for AN. And then for Bn, we have to have greater than 0 value. Kasi nga, andito siya sa denominator. Okay? And so, we define that limit of An over Bn as n approaches to infinity equal to L if L is positive and finite, then either both series converges or diverges. Here is an example. Determine if the series is convergent or divergent given the series 1 over 5 plus 2 raised to n. Okay, we know the given series 1 over 5 plus 2 raised to n to be our AN, and the series 1 over 2 raised to n to be our B raised to n. Again, so this is our Bn. This is from we got it from here, but we just removed the insignificant number 5. Now, in the given limit comparison test, there's no condition whether An or Bn is greater than or equal to the other series. Okay, we do not have conditions that An should be greater than Bn or Bn should be greater than An. But since An is, of course, the first series, so we assume that An is the given series. Okay, and then the Bn is the other series without the insignificant number. Therefore, we get the limit of An times 1 over B raised to n. Now, this one, instead of writing it as An over Bn, okay, the limit of An over Bn, sineparate ko ang An at saka yung 1 over Bn. Para lang mas klaro sa ating, if we're going to evaluate it already. Okay? And then, we have this one. We're going to substitute An. So, An is 1 over 5 plus 2 raised to n. And our 1 over Bn is 2 raised to n. 1 over Bn, that is 1 over 2 raised to n. This is our Bn. And if we're going to simplify 1 over 2 raised to n, it will be equal to 2 raised to n. Okay, and then let us simplify this one. So that is equivalent to, this one is equivalent to 2 raised to n over 5 plus 2 raised to n. And then, to get the limits now, we know that as n approaches to positive infinity, the limit of this entire given fraction is equal to 1. Okay? Again, as n approaches to positive infinity, meaning as n increases in this given quantity or fraction in particular, the entire value of the fraction is, kumbaga yung value ng entire fraction as n approaches to positive infinity is nag-a-approach din to the value 1. That is why our limit is 1. Now, since the limit of since the limit is 1, which is finite, therefore, the two series, which is the An and Bn, are convergent. Another example is, let us determine if the given series n plus 5 over n squared is convergent or divergent. Again, so this is our an, and this is our bn. Okay, they look similar, but without the series bn is without the insignificant number 5. Okay, and then we will get the limit. So the limit of an times 1 over bn. So this is our bn. So for 1 over bn, that will be equal to 1 over n squared. Okay, and then to simplify it, that will be equal to this one. Okay, yan ang equivalent niya when we simplify this one. And then this one is equal to this one because we already cancel n squared, and so we have the limit of n plus 5 all over n as n approaches to positive infinity. Now, as n approaches to positive infinity, the entire value of the fraction is also approaching to positive infinity. Okay, again, as n approaches to positive infinity here, okay, so yung entire value ng fractions ay nag-a-approach din sa positive infinity. Okay, there's no certain value kung saan nag-a-approach yung value ng fractions as n approaches to positive infinity. Continuous lang lagi. Continuous lang. Let's say, when n is 100, so that's 105. So let's say, n is 100, so this is equivalent to 105 over 100. And then, if n is 1,000, so this is 1,005 over 1,000. Okay, so as n increases, yung value naman ng fractions ay nag-i-increase din. Hindi nag-a-approach to a certain value. That is why the limit is positive infinity. Since the limit is not finite, therefore the two series, the an and bn, are divergent. So again, using the limit comparison test, example 1 was proven to have, the two series was proven to be convergent. Okay, the an and bn are convergent. And for example number 2, because using the limit comparison test, the two series, which is the an and bn, were proven to be divergent.